first part of the chapter, Boyle's law, Charles' law, the combined gas law, Dalton's law, collecting gas over water, and the ideal gas law, that's all from Chem 1. So that's all review. You can read that and do those problems on your own. We're going to start with section 5.6. This is new material. And section 5.6 starts with kinetic theory of gases. Okay, and there are 4 points to the kinetic theory of gas. The first point is that gases are assumed to be point masses. Okay, so a point mass means that you have volume, that you have mass but no volume. Okay. So that would mean that it's like saying I weigh 160 pounds, but I take up no space. Well, obviously that can't be the case. If you have mass, you take up volume. So how can they say that a gas has mass but takes up no volume? Well, they do that to make the calculations easier. In a later lecture, I'll explain the difference between ideal gas and real gas and why the ideal gas equation is so much easier than the real gas equation, even though the ideal gas equation is not entirely correct. Second assumption is that pressure is caused by, or not assumption, the second point is that pressure is caused by particles colliding with the wall. Okay. So that is not an assumption. That's what actually causes pressure, is the gas particles striking the wall. Number 3, just like number 1, is an assumption that there are no attractive forces between gas particles. Okay, so we pretend that one water molecule doesn't attract another water molecule, or one hydrogen gas molecule doesn't attract another hydrogen gas molecule. That's not entirely true. There is a very, very weak attraction between gas particles, but we assume that they don't attract each other because, once again, it makes the math a lot more easy. And then number 4, the average kinetic energy and kinetic energy will be abbreviated KE, and the average means a line over it, okay? So if you were to say, what is the average height of something, you'd put a line over it. If you want to know the average GPA in our school, you would put a line over it, okay? That means average. So the average kinetic energy is proportional to the temperature. And we actually have an equation that relates the two. And that equation is that the average kinetic energy is equal to 3/2 RT. Okay? So these are the 4 points of the kinetic gas law. So just to recap real quick, gases are point masses. That's an assumption. Pressure is caused by particles hitting the wall. That's true. Number 3, attractive force. There are no attractive forces between gas particles. That's an assumption. And then number 4, the average kinetic energy is proportional to the temperature of the gas. And mathematically, the average kinetic energy is 3/2 RT. Okay? Now there are just 2 more definitions I'd like to add before we delve into our next video, which is the proof of the proof of number 4 here. Diffusion is when you have 2 gases mixing. So if I have a tube and I have 1 gas on one side and I've got another gas on the other side, and this gas is going this way and this gas is going that way, this is diffusion because you've got 2 gases that are going to mix. But effusion is the passage of 1 gas in a vacuum. So in this case, you'd have your tube, and then you would release one of your gases and see how long it would take to move across the tube. So that's the difference between diffusion and effusion. Okay? The next video will be a proof of why the 4th point here, whoops, this guy is true. Okay?